Hello everyone, my name is Felienne Hermans. I'm a professor at the Vrije Universiteit Amsterdam, where I research programming education. And I'm going to talk today about Hedy, a gradual programming language that I made. And if you don't know what a gradual programming language is, don't worry. The most important things are right here. Hedy is a gradual language, a multilingual language, and a language that is built for teaching. So if you're like very tired of all the talks today and you want to zone out, but you still later at the party want to pretend that you paid attention, you just really have to remember these three things. These are like core ideas of the entire talk on a slide already here. A gradual multilingual programming language built for teaching. But before we really dive into the details, I want to take you through my history of developing a programming language for children, because sometimes if people hear that I work on education, they think I have a background in education, but I have a background in programming language design. Actually, I did a PhD in software engineering, but after my PhD, are there people with a PhD in the audience? Oh, quite a bunch. Yeah, so you maybe recognize this. After my PhD, I was like, that was a lot of work. I'm done with this topic. I don't want to do many things anymore. And then sort of life happened and I started to teach in a programming club for relatively young kids. So between 10 and 14, Saturday afternoons, I would do programming education. I thought this is going to be really, really fun. And I also thought it was going to be easy because also people with a PhD, we think everything is easy. You know, we did a PhD. How hard can it be? Teaching children. I don't know anything about it, but I'm sure I can do it because I'm really smart. This is about programming. I know many things about programming. These are 10-year-olds. What can they ask that I don't know about programming? This will be very, very, very easy, I thought. And then what happened, not very intentionally, but subconsciously, I remembered how I learned programming when I was a kid. So this is me when I was about 10 years old, sitting behind my dad's really big computers, because computers were really big, or screens, I should say, were really big at the time, learning programming. But when I was 10, so this is like in the mid-90s, there were no programming clubs, there were no programming teachers. I didn't know anyone that was a programmer or that knew programming. So I didn't go to a programming lesson to be explained programming. How did I learn programming? For the younger people in the audience, I learned programming from a book. This is a paper device. You can get this in the library. Yeah, you go to the library, you take a coin, you give a coin, you get a paper book. If I tell this to my 18-year-old students now, they're like, but why didn't you use the internet? There was no internet. So I learned programming from a book. And this book wasn't really a book that was a teacher in a book. It didn't have explanations like this is a for loop and this is a while loop. This is what was in the book. Printed out basic listings. And now my 18-year-old students are like, wasn't there like a CD-ROM with the book? Or a floppy with the program? No, you just got the book. And you manually copied the programs into the computer. And for people with a keen eye, this is actually in English, so there was words like velocity in there. You can probably hear that English is not my first language. Velocity. No clue what I'm doing, but you know, there was no internet, no TikTok, no Netflix. What else was I going to do? If I wanted to have a game, this was my pathway into having a game, so I was very motivated about that. And it's not just me. Many people were nodding that also have this experience of learning programming from a paper book. Therefore, we have been somewhat psychologically damaged. We have been Stockholm syndromed into thinking that compilers are great teachers. Because it was the only teacher that we had, was the compiler. You type the code in and then it doesn't work. It gives you some magic feedback in English, you work a bit more and ultimately you do it. So because we lacked any other way of teaching, we think this is a really, really good way of teaching because it's just the only way we're ever exposed to. This was very much my frame of reference when I started to teaching, but it wasn't that clear to me at the time that that was what I was thinking. But what I did was I just, gave the kids some booklets with code and I thought they will copy the codes patiently and with a keen eye for detail in silence. And then if there's a mistake, then the computer will tell them what's wrong and they will learn, like me. They will become PhDs in software engineering in 20 years. And this will be thanks to my excellent programming club. Yeah, but it didn't go like this. just to give you a little bit more context about what we're doing. Initially, we were using Scratch. Who has ever seen Scratch or maybe even used it with kids? Many people. So this is Scratch. If you haven't seen it, it's a visual programming language. You click blocks together and then stuff happens. So these blocks that we have here now, if you would execute the program, the cat would turn around and also meow with just a few blocks of code. This was actually going quite well. But then as the kids aged a little bit, going from 10 to 11 to 12, they would say, meh, teacher, we don't want to do Scratch. It is for kids. It is a childish language. It looks like a toy. And this isn't just because they were aging. It also very much has to do with reasons for programming. The school where I teach is a very much inner city school in a poor area of the country where I live in. So the kids were also very motivated to become programmers because this would be a good career for them. And this doesn't look like a tool that will make you money. So it wasn't just about, I'm too old for this. It was also, they wanted to do something that would feel authentic, like feeling like a developer and feeling that there would be a good career at the end of the lessons. And this just wasn't that. So I said, no problem, children. We will go to Python. Python is a very user-friendly programming language, easy to use. This will be fantastic. Look, this is Python. You know, my basic nostalgia was going. It's almost like basic when I was your age. This is very cool. Look, you do print and then brackets and then quotes. And then, teacher, then do we have a dancing cat that meows? No, you will get text on the screen. Cool, huh? Text. It is on a screen. Just okay. So this was already the first cracks in my nostalgia, because when I was 10, this was super cool. No one could do this. So this was like point of contention one. But then some kids made mistakes. For example, here they would accidentally type an uppercase P at the beginning of a keyword. It's a very reasonable thing to do because sentences start with uppercase letters. This we have taught them in elementary school for 5 years. What does Python say? Does Python easily understand what this means? No, Python says name print is not defined. Yeah, but print is defined though, with a lowercase p. And this isn't even a terrible error message. It sort of explains what's going on, but here's another one. A forgotten closing bracket. You would think a computer that can easily calculate 34 times 7,025 can deal with this simple mistake. It cannot. Syntax error, unexpected EOF while parsing. Teacher, what is parsing? Don't worry, kids, I have the dragon book right here. I don't want to talk about parsing. Okay, I want to talk about parsing, but not now in your first programming lesson when you're just learning print. It is a bit too early for that. Your parents might not approve. So this is a problem. Here's another one. Teacher, I'm sorry about the other mistakes. I did everything perfectly. I swear I checked 5 times. There are no mistakes. Everything is there. It is literally an invisible mistake. What does Python say? A space. Who cares about the space? Of course not. Indentation error, unexpected indent. Teacher, what is an indent? Right? I don't want to talk about these things now. So all these concepts that are in Python, for good reasons, right? We understand why this error message is here. All these concepts that I don't want to talk about sort of jump into your classroom, and you cannot say, go away, indentation. Not now. I'm busy with print. This is complex enough. So after a long while, maybe like a year or something, I realized, you know what? Maybe compilers are not lovely teachers. Maybe humans need to do a little bit more work to actually teach programming languages to kids, because just leaving it up to the computer isn't really a good strategy. What I also realized is that I was really having a different conversation with the kids than the kids were having with me. I would show something like this. I would say, look, repetition. Isn't it magical that that one line is repeated 4 times? I wanted to talk about the big concepts of programming, but showing this to a kid, they're just going to be distracted. They're like, oh no, many things, brackets, and a colon, and spaces. They were so distracted by all the syntax that I was saying, look, it's repetition, but they were just seeing all the weird characters, not really picking up on the concepts that I wanted to talk about. And I got sort of nerd sniped. I was like, wow, I want to know everything about this. These children have functioning brains. They can read, and they can speak, and they can do math. So clearly, it's not them. It's me. They can learn something. They just cannot learn programming from me. So I got interested in this idea of how do other fields teach things? Anything, basically. Specifically, language is really interesting. If we teach language, writing, to, let's say, a 6-year-old, then they initially do something like this. And we wouldn't say, syntax error, unexpected floating A. To a 6-year-old, we would say, well done, buddy. That's almost like a letter. Here's a sticker. Practice a little bit more. We gradually add rules. We say after a while, if they know the alphabet, oh, look, you can also make words. And then we say, well, actually, there's a rule that sentences start with an uppercase letter. Not in Python, but in English and Dutch. And then they acquire that rule through practice. And then we say, you know what? Sentences have to end in a period. And then they practice that rule. And this is not just syntax. It's also expressive power. With a capital letter and a period, we're adding expressive power to the language because now we can do sentences that span multiple lines. Initially, a line and a sentence are the same for a novice writer. And then now we say, oh, look, because we have unlocked the periods, you can make sentences until the next line and stop in the middle. Very cool. So we're adding syntax, but also we're adding and refining concepts. Math also does this. So in math, you have changing rules, for example, for subtraction. Initially, we explain subtraction often to kids as cookies that are shared. So I have 5 cookies on the table, and there are 3 kids. And now 5 cookies have to be given to 3 children. How many cookies are left on the table? We might even give different words to subtraction initially. In English, you might say 5 take away 3 rather than 5 minus 3 to emphasize that taking away that subtraction means. Then in this mental model, 3 minus 5 actually equals 0, because I have 3 cookies, but I have 5 children. Now, how many cookies remain on the table? 1, 2, 3. Now we're out of cookies. Only later we say, well, you can have 2 cookies debt to the cookie bank, so now actually you owe me 2 cookies, and tomorrow you will owe me 2.5 cookies. So this mental model is gradually changing. And this is also true for division, for example. Initially we say 8 divided by 3 is 2 remainder 2. And then it is 2 2/3. And then it's 2.666666. These mental models gradually change. And children's minds, despite maybe popular belief in computer science, aren't crippled by changing mental models. This is normal and a healthy process of education. It might be mildly annoying to switch mental models, but it's also mildly annoying to do differential equations with 6-year-olds. So you just have to make the problems very small and then gradually build up to bigger systems. So I guess you sort of see where this is going. Then I thought, well, a programming language could also do this. I happen to know a little bit about programming languages, so I could build a programming language that also gradually changes syntax and gradually adds concepts so that it's easier to learn. So that's the Hedy programming language. Let's look at a demo. So this is level 1. And in level 1, one of the only things you can do is just printing. So you have print hello world, no brackets, no quotes, this just works. So I can also say hello NewCrafts, and then this works. You don't have to do anything in addition to printing. But there was one other problem that I mentioned, right? That kid said, well, just text on a screen is not very engaging. I wanted to make it interactive from the beginning. So in level 1, we don't just have print, we also have ask. So I can say, how are you? And then it will ask, how are you? And I can say, good. And to make it a little bit more interactive, because now you could still say, well, I could type this in words, it also allows you to repeat the answer back. So you can also say, so you are, how are you? Still good. Then it says, so you are still good. So there's the introduction of state. This variable, this value is stored somewhere, but it's not necessary for the kid to think about that yet. They can get used to the idea of, hey, computers can remember something you tell them and you can use that later. And also they can get used to the mechanics of programming. There's code here, there's output there, there's a button you have to press so that the code will be executed. And you know, if you have to imagine you would have to do this already in Python, you would have to do something like this: input, la la la, how are you, right? And then print, so you are, oops, so you are, and then A again. And some kids would get so distracted by this that they couldn't think of the idea, which I wanted to them to remember. Hey, there's a value that you can store. So this is level 1. Let's go to level 2. In level 2, we introduce explicit variables. So now we're saying, hey, that value that you can store in the computer, you can give it a name. So you can say name is Hedy, for example, and then let's do hello. So you can see it's actually a live demo. And then it says, hello, Hedy. To us programmers, this is magic, right? But wait, hello is a string, but name is a variable. Oh no, this is so confusing. We have to tell the computer what is what, or the computer will be confused. The computer is not confused. You are confused, right? And it's very weird that this is also done to my brain. Now I'm programming in Python or I'm programming in TypeScript. It annoys me that I have to put the quotes there. You have interpreted this program. You know what the variables are. Why am I telling you where I want a variable? Sometimes it doesn't work, but in many cases it could do some mild guessing. But for kids, this actually works really well because they can focus on the idea of a variable without any of the fluffy syntax. Let's go to level 3. In level 3, we add, in addition to normal variables, also the option to add lists. So you can say animals is cat, dog, parrot. And then you can print animals at random. And this will give you a random animal. We explicitly introduce lists immediately with random to show that programming is somewhat reasonable thing. Like, look, you can make a list and then you can retrieve an element at random. So you can make a nice, fun, interactive story. And you can say something like, print, oh no, there is a... Oh, that is not necessary yet. Just talking about how not necessary that was. So now this will give you a very small random story. Oh no, there is a car. It's a car. I didn't notice. Very random. A parrot in the forest. Because what was also annoying me very much is code samples, code snippets that we were teaching that were just like unreasonable. Something like animals is cat, dog, parrot. And then here you would do this, right? You would print number 1. Kids would be like, then why am I putting it in a list if I'm just retrieving one element? So we're really trying to have this authenticity to make programs that look like programs that professionals would make. If you put something in a list, you are not going to retrieve an element with a constant. That's just not a thing that makes sense. So that doesn't make it a good example. In level 4, then, we add quotation marks. So now kids have seen some fun things and they've created some interactive stories. And then we say, well, sadly, it is the real world. There are some rules we have to obey, but we let them ease into it. And then we just do quotation marks. So that's the only thing we add in level 4, so kids can really, really focus on this new rule. So if you run this, it works. A benefit of a small language is not just a cognitive benefit that is easier to learn, it's also easier as a language designer to process wrong programs because there are not so many choices that can happen. So if you make a mistake here and run this, then it will say, hey, be careful. If you ask or print something, the text should start and finish with a quotation mark. You forgot that for the text, hello world. Because the language is so small, it's a lot easier to pinpoint mistakes and to guess what the kid was doing. I don't have to hypothesize, oh, maybe it was an indentation. Maybe this was a function call, because all these things aren't there. So we can be a lot more precise and descriptive in error messages. We're not going to do all levels. There are 18 levels, just so you know. And the final level, level 18, is a functioning subset of Python. So we really gradually bring kids to Python, and then we sort of open the curtain and say, ta-da! Now it's Python. And from here, you can actually go out into the Python world and do programming in a professional language. This is really to have this authenticity that, yes, this is also still like Scratch, a toy language, but it is really a toy language that with every lesson, every week, looks more like a professional programming language to the point where it will become one in a few months. So that was a demo. Let's talk a little bit about how this was implemented. I don't have time to go into all the details, but just to give you a sense of what's underneath. So we have Hedy code. This is the code that the kid writes. We have a grammar. This is a text that describes what Hedy code we can expect. So you can have print followed by text, or ask followed by text, or echo optionally followed by text. From a grammar and the code that the child writes, we create a parse tree. And the easiest way to think of what we do is we generate Python from the parse tree. So we just put in the brackets and we put in the quotes that the kids didn't need. So then we have Python. So for the grammar, we use a framework called Lark. That's just a parser framework. So I didn't have to write the whole parser, just the grammar. And then you saw that we run in a website. So for the website, we use Scope. That's a JavaScript re-implementation of Python. So we generate Python, and then the browser interprets the Python and does that with JavaScript. So this is the basic architecture of the system. You might think, Felienne, why didn't you immediately generate JavaScript? Why did you first generate Python and then interpret Python in the browser with JavaScript? That's because I didn't think it would be an actual big project. And this was the easiest thing to string everything together. And then before I realized it was a little bit bigger than I could control, and then it was too late to change anything. So this would not have been my preferred architecture. Had I known, I would have actual users. It was a mistake. So that is the gradual nature. We talked about the gradualness. Hedy is a language that slowly adds concepts and slowly adds syntax up to Python. Let's talk about Hedy being multilingual. When I created Hedy, I started to ask kids, hey, what do you think about it? Do kids actually like Hedy? So we did a user study with 39 kids. These were 11 to 13-year-olds in 12 online lessons, because it was the pandemic, so we couldn't go to schools. And we asked kids, what do you think are the benefits, the challenges, and the improvements we could make to Hedy? Because we didn't know initially, of course, would they actually understand it? Would they think it is an authentic language? Maybe they wouldn't think these things. So kids said, and this was really nice, that the levels are really a step-by-step guide. It tells you what to do. I thought, oh, that's interesting. Because there are many other issues that I didn't really think about, like Scratch nor Python really tells you what to build. And this was never a problem for me as a kid, because I had this imagination, like, oh, I can build anything. But not everyone is like that. Some kids, they really don't know what is possible. They don't know what they want. And these levels just tell them what to do to spark creativity. If you really have no idea what you're going to build, you also cannot be creative. What I also very much like is that one of the teachers in the school where we did this said, We used to do Python before, and with Python, some kids learned a lot of programming, but a big chunk of the kids didn't learn anything. It was just so complex, they just wouldn't pick up anything. And he said, with Hedy, all kids learn some programming. They don't all make it to level 18. Some only make it to level 5. But then they've already seen variables and lists and conditionals. Those are in level 5. So they've seen something and they feel like they can do something with the machine. And I thought, yes, that's the goal. What I also very much liked is that a female teacher in this school that was only teaching female students said, "Did you make Hedy for girls?" I was like, no, not specifically, it's for all kids. But she said, girls so very often have very low confidence in their own ability in technology. They come into a programming class and they think, I will not be able to do this. Sometimes because they're literally told that by their peers or their social circle, sometimes even their parents. They'll come into programming class and say, my dad said this is really hard. You know, and maybe the dad was even trying to be nice, but still, if you think this is hard and if you think this is not for you, the first thing you see is unexpected syntax error. You'll be like, oh no, my dad was right. This is really hard. So even though error messages might be neutral and not like sexist, the fact that we as a society, we tell girls programming is hard and not for them means that the same error message really hits differently based on your prior knowledge. And that's not just girls. This is also kids that might come from a household where there's not a computer. They might also think, oh, this is scary. Maybe I'll break the computer. And then it shouts at you in red letters. You're like, oh no. So confidence is really, really related to error message in ways I had never thought about. So I thought, wow, that's such a cool quote. We also asked kids, what are the challenges? Like, what makes Hedy hard? And they had some really nice ideas. They said, wow, it's still very hard to remember the right codes. Even if there's just a few, it really has to go in your brain. And they said, things suddenly change. We don't like that, which is, yeah, it's like the harsh reality of learning. We have worked a little bit on making the transitions between levels a little bit smoother, but yeah, there's a little bit of unlearning to do. That's core to the idea of Hedy. Kids also said, we have some suggestions for you. For example, we would like better error messages. It's like, okay, well, I already think it's quite good. Have you seen Python? But these kids had not seen Python, right? So I said, okay, well, tell me about an error message. And they showed me this one. So I think this is actually quite good. There's a comma there. This is not allowed. The parser confuses this with a list assignment. So you cannot have a comma there. And now in this error message, it says exactly where the mistake is. Line 1, position 12. It explains to you what is wrong. So it says, kid, read this error message to me. Because I figured they're not paying attention. They just haven't looked at my precious, fantastically designed error message. So this kid goes like, sure, I will read the error message. It's very unclear because it says, there's a mistake on line 1 at position 12. You typed, but that is not allowed. What do we teach kids about commas? If you see a comma, you take a little pause. For 5 years in elementary school, they were racing over the commas. And this elementary school teacher, with great amounts of patience, has drilled into them that you need to take a pause if you see a comma. It's like, oh no, it was me, after all. And this is like the type of stuff you really only get if you directly sit next to users. I mean, I could have gotten this from the database log, seeing that this was not a good error message. Not in a million years would it have occurred to me that a comma means a pause, even though, of course, I know that's what it means. So now this is actually a thing we changed. So now all error messages spell out characters. So now it says you typed a comma or a exclamation mark. That transfer, of course, is a little bit of work, but this makes it a lot more clear what's going on. So this level of detail of iteration was really, really helpful in making the user interface better. What kids also said, so these were Dutch kids in the Netherlands where I live and teach, they said, why can't we program in Dutch? Yeah, why? Yeah, because I didn't build it. That's why. I didn't really think of it. And it was interesting because initially I was very reluctant. I was like, yeah, but you can just learn English. It's not so hard. I did it. But they were like, but why, though? You're the boss of this. Why can't you just put Dutch in there? It's like, well, because it's a lot of work. But it was a pandemic, so I didn't really have much else to do. So let's look at a few Hedys. So this is Hedy in Spanish. Because the interesting thing was, once we built Dutch, other people started to contribute. And we got French and German and Spanish. And then when I was seeing this, I thought, oh, imprimer hola, that's very different from print. And my language, print is print. And echo is echo. So it's not really a difference. But then I thought, yes, the farther away you get from English, the more sense this makes. After a while, people also started to introduce non-Latin languages. And I thought, yeah, those kids in my school were not so crazy for asking for their own language. Right? Imagine this is your language. We're going to do Python. We start with print. It starts with a P. Teacher, what is a P? And how does it differ from a B and a D? Right? This is so hard. It's such an extra barrier to programming that we had all these languages. And I was like changing my mind all the time because initially I thought, I'll just build it so I can tell them I built it and then I'll never touch it again. And then it's like, wow. So then I was feeling very, very happy about myself. But sadly, one of my best friends comes from Palestine. And he said, yes, so impressive. These left to right languages. Well done, Hermans. This is so cool. But what about Arabic? I was like, well, this is a lot of work. I don't want to do that. But I did because it was still the pandemic. It went on for a very long time. So you can also now program in Arabic. Everything is right to left. You can run the code. If you make a mistake, which is not so easy actually, but if you do, then you'll get an error message in Arabic. This is sad because it's browser caching. If you do it a bunch of times, it will also be in Arabic. Oh, and we currently, let me brag for like 1 minute. We currently support 47 different languages. So just because the organization said we are not at all in a hurry, I'm going to take you through a few parts of how I built this. Because it was a lot of work. The first step, just the Dutch part, was not so very hard. I figured I'd just make a copy of all the grammars, and I just take ask, and I swap it out by vraag, which is the only change you need in the Dutch level 1. So this is easy. I just copy-paste the 18 levels into one other language. This will be fine. But then some people that are smart and have thought about this a lot had some ideas for more work. Mark Guzdiao is also a computer science professor in the US, and he works a lot with Spanish-speaking people in the US. And he said, yeah, but you shouldn't limit it to one language, because bilingual people will want to mix different languages together. we actually support that also now, but only with English, because otherwise it will be a parsing nightmare. So now we just have any language or the English equivalent in the grammar. So that was still very much okay. So as I said, I was very happy, but then my friend Alan in Sweden from Palestine, Arabic speaker, said, yeah, but now you do Arabic. And I'll talk a little bit about some of the things that it has entailed to make Hedy both non-Latin, so non-A to Z, and also right to left. Let's start with variable names. Variable names are very interesting because, as all the other things I will talk about, I never thought about it. I didn't even know what the definition of variable names was in my own language, because I just took code from a framework. I used Lark, and Lark has built-in support for variable names. So I just had this import Lark give me a C name from Lark. And I don't know about you, but I never read code from libraries that I use. Am I the only one? No. Okay, I heard one no. Thank you, friend. So I had no clue. I just tried, do Arabic variable names work in Hedy? They did not. Okay, let's see what's actually in there. What is a C name? Okay, it's a letter or a digit. A letter is an uppercase letter or a lowercase letter. And if you know a little bit about internationalization, already now your spidey sense should go brr, 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 brr. Because not all languages have uppercase and lowercase letters. So if there's something like this in your code, probably it's not going to work. And this is the definition. So I was not supporting any non-A to Z characters in variable names unintentionally because I was too lazy to actually read what I was using. And this is not even only relevant if you want to do Arabic keywords or French keywords. If you have a program like this in French, répéter is ask combien, print on y va répéter fois, which is, I think, a reasonable program in French. This doesn't work because this variable name already isn't supported by A to Z because these two characters are also not in between A and Z. So it's not just for, let's say, from my perspective, weird languages that are very far away. Even in my own language, there are characters that have accents that wouldn't be supported. So I was like, wow, this is worse than I thought. So we actually replaced this by the Python definition of variable names. Python does support non-Latin variable names, but the sad reality is then if you actually copy from Python, which we did, the definition of variable names, you get this. And this. So this is all possible letters followed by all possible numbers in all numerical systems. So it's better than A to Z, but it also makes your code maybe less readable because you need extensive documentation to explain what's going on here. Let's talk about right to left parsing. So the parsing in Arabic is not going left to right, but it's going right to left. So the parser will go this way, but in Arabic it will go the other way around. This is actually easy. This is the part I was worried about. I was like, oh no, I have to swap all the stats and everything will be very complicated. But this is easy because in the computer, the text is always stored, from my perspective, let's say, left to right. So the first character that a person would read is always the first character in the byte sequence. So that is not hard. You don't have to do anything special for right to left parsing. So this, in principle, just works, but it gives you interesting situations when you're debugging. For example, if you're printing for debugging purposes this string, you will get this. But then now I really want to have the first character, because maybe something's up with the first character, then you get this. So it takes my brain still a while to process what's going on here, right? I can sort of do it now, but I would expect this is input string 0, but it's actually this one. So the presentation is entirely left up to programs. Internally, it's always the first character that a person would read is character 0. Does anyone see an issue with this? I'll buy you a beer at the party if you can figure out where this might go wrong. All the way over there. Sorry, what was that? What is the word in between left to right and right to left? Oh, yes, mixing. Yes, that is definitely a problem. If you want to mix, then sometimes programs will mess up stuff. But there's another problem even. Yes. When you print it, oh, that's a good one. Yes, when you would report which character is wrong by numbers, that would also be wrong. Many issues. The actual issue that I thought, oh no, how will this work, is about brackets. Because if you go this way, the first bracket you would see is the wrong bracket. It's like, oh no, I have to swap out all the brackets. But you don't actually. Sometimes computers are your friends. Sometimes they actually have their stuff mildly in order because fonts fix this. So if you're an Arabic keyboard, they will show you a closing bracket, but internally they will know it's the first one and internally replace it by an opening bracket so that it doesn't confuse parsers. Like, wow, that's cool. But presentation is up to programs is not only a benefit. So if you have a program like this, then if you would open it in Hedy, it looks like this. But then important to know, for Arabic words to make sense, letters have to be connected. So what you see here, for example, these are two separate letters, but this line in between matters for understandability. You cannot remove that line because it's then not readable. It doesn't mean things. So PyCharm doesn't really render PyCharm renders this correctly. So this word is correctly, this is the same variable as there. But not all programs are PyCharm. In a large part of my life, I avoided using Vim. I didn't really like Vim very much because I felt Vim didn't really like me. If you open Arabic text in Vim, then your suspicions about Vim not liking you are confirmed, because this is what Vim does, which is nothing. So it doesn't at all swap anything. It just says, yeah, this is the byte string, so this is the first character, yeah, that's the second character. But then some words don't make sense because they're not connected in the right way, because the different letters are in a different order, and it doesn't mean anything, which I really like for debugging Arabic text, because it doesn't mean anything to me anyway. So now it's in my benefit that Vim doesn't do anything for me, because now I don't want it to do anything. But it is very, very confusing if these words are your own language, because then it's basically unreadable. Let's talk about numbers. Fun fact that I didn't know, let's say a year and a half ago, what we call Arabic numerals, it is not what people that speak the actual language Arabic actually use. They have different numbers. I didn't know this. So when we made a leap into Arabic programming, I was happy. We have keywords. This is repeat 3 times. This is print. This all works. But that 3, I was going to my friend Aladdin, look what we have. He's like, that's not a 3. Oh no, what is a 3? It looks very different. So far it was going well. The keywords were going well. This actually is also an interesting thing to point out. This string uses negative parsing. So how we deal with text now, rather than saying text should be A to Z, we just say what it should not be. So we just say anything is text, as long as it's not a new line or a comment character, anything can be parsed. And if you take away something from this talk for your own implementation, this idea of negative parsing is a really strong idea. So if you have an input field somewhere, don't think about what could this be? Oh, A to Z, because that's the only thing I think is a letter. Think about what it actually cannot be, and define your regular expressions or your grammars in a way that excludes things, that break things, rather than limits inputs for no good reason. This idea of negative parsing is actually not my idea. I want to credit someone that has done a lot of work for Arabic programming languages called Ramzi Nasser. He's made some really cool stuff. So maybe you've heard of Dialog 3D. This is a Wolfenstein clone that he built, but then every time you want to shoot a Nazi, it doesn't allow you to do so. It says, wait, is it okay to shoot Nazis? Don't you want to engage in some healthy dialogue? And with every shot, it gives you this pop-up, and then it sort of renders the game entirely unplayable. This is a thing he made. Maybe there's a lesson in there. But he also made ELB. And ELB is the first programming language in Arabic, which is a translated version of Lisp. And this was such an inspiration. I learned so many things from him about how to design such a system. Just wanted to credit him for that amazing work. So, we're going well. Print, times, repeat, strings, everything's working. But that 3, though, it's not really a 3. This works fine, and this is the corresponding Python. So what I do is I transform that, parse it into Python. No problem. Now I put in Arabic 3. I think this will be fine. Python can handle variable names with Arabic numerals. This will be fine. It was not fine. And then I was like, but look at that error message. That is an interesting error message. Why does it say invalid character in identifier? Why does it think that is an identifier? Why is this parsing that as a variable name? Interesting. Let's dive in a little bit deeper. So if you just assign a number to a variable like I, you print the variable in Python. Of course, this works. If you assign I to a variable, this is a g and then a 3, you cannot print this variable because it's not defined, right? That is a reasonable thing. I try to define a variable that starts with a letter and then a number, but this variable doesn't exist. Notice, though, when I said presentation is up to programs, how the Python editor and the Python error message do not agree on the order of the characters. Like, this is taken from the same window. So this is what I'm typing, but my error message reverses the characters. Because a sideline that was also annoying me. But this is interesting. So if I define a variable, the variable doesn't exist. Okay, I get a mistake. But now, if I have a number, it doesn't say this variable name doesn't exist. It says this is an invalid character in identifier. Remember when we were looking at the variable names in Python? You cannot start a variable name with a number, including an Arabic number. So this is like Schrodinger's number, because it's enough of a number that you cannot start a variable name with this number. So arguably it is a number because you cannot start a variable name with a number, but it's not enough of a number to actually be a number. Like, I'm the only person. Now you have all to share my agony. You're the only person that has ever thought, this is unfair. If it's a number, it's a number. Then I can start a variable name. Cannot start a variable name with it. Or it is not a number. And then I can start a variable name. And that's only fair. Schrodinger's number. So this didn't work. Thanks. Luckily, this does work. So, I mean, Python does have some stuff in order. If you actually put the Arabic number 3 or any of them in between quotes and then print it, then it will actually print 3. So it can coerce a string in another numeral system into an integer, and then it knows what integer that is. That's actually pretty rad. So that's what we use now. We take the number, we put it into a string, and then we cast it into an integer, and then it actually works. But remember, I said we use a framework. That was a mistake. That is a re-implementation of Python in JavaScript. Is it a full re-implementation, you ask? Of course not. No. So you are super happy. All my tests are passing. Running it in the browser. Bam. Oh no. They didn't implement this in Sculpt. Again, someone that isn't making my life better. So now I have actually this in my code, which is overriding the built-in int with my own int to force the numbers to be transformed, which is nice. Students ask me if I explain to them in Python, you may override a built-in function. They was like, why would you ever use that? Do I have the story for you? So this actually also works in the browser. So this now works. So I'm like, Aladdin, I fixed it. You can input your numbers and then it works in a repeat loop. Ta-da! It's like, what is that output? That's not my numbers. Oh no. Okay, you also have to do the conversion back. So now I have yet another horrible function in my code that does everything converted back in the output. So if you now run it on the website, you can try it, then it actually outputs by going into my English numbers and transforming it back, which of course, like, from a philosophical standing is not what you want, but you have to go through this intermediate layer of whatever Python agrees are actual real numbers in any use of it. Okay, one more thing. I promise this is like the last thing. The order of numbers. So I thought, well, if you come from this way, then this is the 1 and this is the 0. So surely this is 10. Because the 1 is the first thing you see. It was not. I was making mistakes and assumptions again. This is actually not 10. No, this is 10. So then here you have to do a little bit of reversing because the numbers are in the left to right order, whereas the rest of it is in the right to left order. What can I say? It was a fun 6 months of working on this every day. So Hedy is also multilingual. Isn't that nice? Thank you. Finally, a small thing I want to point out, and this is something I really only realized very late in the process, that Hedy is a tool that is built for teaching. Initially, I don't think I really fully understood that a tool or a programming language built for learning is different from a programming language built for teaching. And because Hedy, like I think all programming languages ever, was made by a person to solve their own problem, what I was solving was the problem of teaching programming, not the problem of learning programming. So we had all these features, and we're adding more of these features as I'm realizing more what I'm actually building to allow teachers to teach more effectively with Hedy. Because when children said in the experiment that these levels are step-by-step guides, teachers also said this. Teachers said, it is so nice that you constrain what kids can do. Then I can learn a few commands, and then I can learn a few more. It doesn't require me to know everything about Python. I can get started without knowing all the concepts that there are. Because teachers, I've taught programming to many teachers, elementary school teachers, middle school teachers. You can explain programming to them, but then they look at Scratch and they're like, yeah, I understand the concepts, but what do they do practically in class? They have to go through all these different lesson plans. They don't really know what is what. And that's really a factor that is hampering adoption of programming education, specifically in school settings, where teachers just don't know what to do with programming. So what we have, which I didn't really fully show before, and let's go back to the English version, is we have all these what we call adventures here. So we say, this is what you can do in level 1, and this is what you can build with it. So in level 1, you can build a parrot. You run the code. What is your name? Let's do Romeo. And then it says, Romeo, Romeo. So it just gives you a teaser. Look, this is what you can build. And then if a teacher or a student don't know what to do with it, then the whole interface takes you through ideas to get your creativity going. You can make a parrot or a haunted house or a story. We also support turtle graphics. So you also can make little drawings. Give these teasers, and then the teacher doesn't have to make a plan. They can just open the interface and all the lesson plans are right there in the interface. What I also realized is that if you have many students in your class, so not 5 in a programming club, but 28 or something in a class, they will all do very different things. Right? Imagine this is your lesson plan, then maybe there's one child that has actually built the lesson plan. You're like, well done, buddy. You're my favorite. Don't tell the other. Yeah, fantastic. But you also have this kid, like, they look at the lesson plan, they're like, oh no, that's many things. I will do one thing. And then I will ask the teacher if I'm on the right way. Like, teacher, is this correct? What do I do now? But you also, on the other end of the spectrum, have maybe people like tiny Felienne that have thrown away this booklet because they already know all the things. Look, teacher, I made this. Isn't this amazing? But I want now I want the tree to be blue. That's what I want. You have to tell me how to do it. Like, no, I don't have time to deal with you because I have 27 others. And I think initially when I was teaching, these kids were the ones I was engaging with most. I was like, that's cool, a blue tree. Let me look at all your 500 blocks and all this crap that is disconnected and not doing anything. So you want to engage them and you want to help them. But as a teacher, it is also nice to somehow limit what kids can do. Because these kids, frankly, aren't really the problem of the teacher, right? They are having fun. You can just say, do something else. So what Scratch and other educational systems, I think, lack is a way to somehow control what kids are doing to make it easier to teach. And this is an interesting tension between maybe you want to serve all kids, but also you want to not run around and deal with these types of problems. So what we allow teachers now is to customize the whole user experience that their students have from the interface. So let me log in. This is actually my actual teaching account. This is why I'm called Miss Hermans. But this is a demo class. So what you can do is you can customize your classroom. So I can say, well, in level 1, I don't want all these adventures. I just want to have 2. And you see 2, 3, and level 4, they are just blocked. You cannot go to level 2. And I can say, I don't want to have the keyword switcher. I don't want to have any of this. And then the experience for the students in my class. So now I'm logged in as a class in that student. This is how it would normally look. But now if I refresh, this is the only thing I'm seeing. So I'm only seeing 2 adventures. And I cannot go to level 2 because this is not unlocked yet. And teachers are even allowed to upload their own lesson plans so that in an additional tab, their content will be in the user interface. So as a teacher, if you want to, you don't have to use this, but if you want to, you have the power to somehow control what kids are doing in your classroom. Today we do level 2. And if you already know many things about programming, congratulations on already knowing C++ when you're 12. Well done. Go do your German homework, right? Go read a comic book. Don't bother me or any of the other kids with your hobbies, because the beginners also need time to catch up. And I think I really didn't realize what a superpower that was, to be able to keep the cohort together, because it allows the beginners to just also reach a certain level of ability before they're exposed to these other kids that already know all the things. Because you might think, oh, what's the harm in a kid already being at level 12 or a kid already making this Scratch program? But that's because most of us probably were that kid. This is what we understand. That's where naturally maybe your sympathy goes. At least my sympathy naturally goes there. But that means all energy I'm spending there, I'm not spending on the beginners. And that's the kids, I want to get into programming, because probably the kids with the gigantic Scratch blocks, they will be fine. They already like programming. So that's everything I wanted to share. If you want to know why Hedy is called Hedy, Hedy is named after Hedy Lamarr, a famous movie actress and also inventor. She invented an algorithm called frequency hopping, which is also in your Wi-Fi router, that if a certain frequency is full, it hops to a new level. That's why it's such a good namesake for the Hedy programming language. If you want to help out, we would very much welcome your help. There are many different ways that you can contribute. For example, if you're interested to work on a very innovative parser that's doing cutting-edge work in multilingual parsing, then you can do that. This is a paper we just published last year, and this second author is actually one of our open source contributors that's in South America that I've never met in real life, but he contributed so much to the parser that he's a co-author on a paper that we wrote about how it's designed. If you're interested in adding translations, that would be nice. 47 languages, could be 50 by the end of the week, who knows? This is what we currently have. And as you can see, not all languages are complete. Sometimes people start translating and then after a while they're like, well, this sounds like a lot of work. Never mind. Like, seriously? So there's languages that aren't complete. You can add to the languages we already have, or you can start new languages. We have a system called WebLate, where you can just log in and translate in the browser. So you don't even need to do very complicated stuff. If you think, oh, this is so cool. I know I'm a teacher, or I know someone that is a teacher, definitely let them in the Hedy community. We have a lot of teacher-facing materials, YouTube videos. You get a little training course if you sign up as a teacher, which is entirely free, by the way. So if you want to bring this to teachers, we'll be very, very happy to have more teachers. The easiest way, you can just go to hedy.org/join to find all the information about how you can help Hedy grow more. Thank you so much.